Right, going back the other way, so converting to magnitude direction form from component form. So we're going to have a vector A, and vectors should be underlined. It's going to be 4i plus 2j. So across 4 up 2, and that gives us the vector A. And then to convert this into magnitude direction form, we need to find this angle and the length of the line. So the magnitude of A, or the length of the line, is written like this. So it's the same symbol as a modulus symbol actually. So magnitude of A. You'll see some vectors written in bold in textbooks instead, but in your working you'll need to underline them. And that's equal to the length of the hypotenuse. So square root of 4 squared plus 2 squared, which is equal to root 20. And then to find this angle, we're going to use trig, so we know that tan of theta is equal to opposite over adjacent. So 2 over 4 is a half, and that gives us theta is 26.6 degrees. So A is square root of 20, 26.6 degrees in magnitude direction form. I'll go over a couple more because you just need to be a little bit careful with the angle. So let's start a new board. So let's do B, which is equal to minus 5i plus 4j. So we're going back 5 and up 4. So finding the magnitude is straightforward, so that's just Pythagoras. So magnitude of B is the square root of 4 squared plus 5 squared, which is the square root of 41. And the angle we need is this angle here. So we need the angle going from the positive x-axis in an anti-clockwise direction. But to get to this angle here, we need to think about this one here, which I'm going to call alpha. And then we can use trig to find alpha. So tan alpha is equal to opposite over adjacent. And that gives us alpha as being 38.7 degrees. And so theta is equal to 180 minus alpha, which is 141.3 degrees. And so B is root 41, 141.3 degrees. So we need to get this angle positive direction anti-clockwise from the positive x-axis. And I'll just do one more. So vector C minus 3i minus 3j. So going back 3, down 3, and we've got this angle here. We might be able to see what that one is actually, but we'll work through it. So there's alpha, but I am actually looking for theta, which is the angle right the way around on the positive x-axis. So tan alpha is equal to 3 over 3, which is 1. So we're just using trig with lengths to find alpha. And so theta is equal to 180 plus 45, which is 225 degrees. And then the magnitude of the vector using Pythagoras is square root of 18, which is 3 root 2. And so C is 3 root 2, 225 degrees. So if you could have a look at doing page 249, question 1, question 3, question 5, and question 6, that's converting into magnitude direction form.